This
that
conference will now be recorded.
so we'll discuss about different topics, whatever we are going through it, and what is the flow. So it will give a complete picture about the entire course. So we will discuss that today. So let me open up. So there's the first day. So I hope the people slowly catch up. So what we'll see is with the entire curriculum, whatever we are designed, it is divided into say like 16 modules. So we'll see how we start the basics and then how we go deeper. So first a few topics would be understanding about foundations of data science. So whatever we are covering in the demo, end-to-end life cycle, or understanding of what is data science, what is artificial intelligence, what is machine learning, what are the subtle differences between data science, machine learning, and artificial intelligence, how are the different approaches in machine learning, different terminologies, whatever we're using. So first a few days, we will be discussing about these topics, which will provide us a foundation on the areas of data science, machine learning, and artificial intelligence. Once we have a foundation on all these topics, we will get into something called as mathematics for data science. Mathematics for data science is very important. Many people say that, anyway, I'm using coding, so why do I require math? Because I'll be directly using some of the functions. I can directly make use of the functions and get my work done. Partially that is true, but it is not really true, because by doing mathematical things, by understanding the math behind the concepts, we will get a lot of solid understanding. So we will have a great understanding on why these components are designed like this. How is the linear algebra helping to create some kind of matrix based operations? What are eigenvalues? What are eigenvectors? What are scalars, vectors, and tensors? How do you do different types of probabilities? What is a conditional probability? What is calculus, and how do you apply calculus, especially the differentiation, gradients, and cost functions? See, all these concepts, which are mathematical concepts, but they are very much used in data science. So when you want to understand all these concepts, it is better to have a deeper knowledge on these concepts. When you have those deeper knowledge, then you can clearly understand why somebody is doing so and so, why this algorithm is applied, what is it trying to do, and how is it trying to do. All these questions you will have clear answers. So we will have a very good foundation on mathematics for data science. We will discuss about different mathematical concepts, discuss about machine learning, artificial intelligence, and other concepts. Once that is done, we will get into statistics for data science. Statistics is, again, you could say, like a subfield of mathematics, but it has its own preference. You have two different types of statistics which we'll be doing. One is called as descriptive statistics, which is like describing the data. So different types of data, what are the measures of central tendency, what are the measures of dispersion, range, quartiles, interquartile ranges, measures and shapes, different variables, random distributions, probability distributions, standard normal distributions, probability mass function, cumulative distribution function, and so on. And then inferential statistics, which is like statistic sampling, different inferences, hypothesis testing, null and alternate hypothesis, margin of error, what are the different types of errors which could be formed, type 1 and type 2 errors, how do you perform different types of hypothesis testing, one-sided, two-sided hypothesis, what are different types of inference tests like chi-square test, t-test, analysis of variance, or we also call as ANOVA. What is a t-value, what is a p-value, what are the different confidence intervals. See, all these different concepts which are having two different layers. Uh, first one is the descriptive statistics, which talks about the description of the data, and the second one is called as inferential statistics, which we are trying to create inferences from our data. So these are the two important statistical functions, statistical areas which we'll be covering, which gives us a very strong understanding of statistics. So what we are doing, we have a basic foundation of data science, then we are getting foundation on mathematics, then we're getting foundation of statistics. Once we have all these things, then we will get into Python for data science. Yesterday we are discussing that one language, if you are familiar with, then you have comfort in writing codes on data science. The language is Python. Now, Python language, here we are not talking about the basics of language. For example, how do we do variable definition? What is a function? What is a loop or array? So we are not going to discuss about all those basic concepts. That you could either get it from some videos or recordings or YouTube or anywhere else. You will be able to get some basics of that. What we will be talking is advanced Python concepts, which are very specific for data science. There are very specific libraries, for example, NumPy, Pandas, Matplotlib, Seaborn, Jupyter Notebook. Likewise, there are different types of libraries which are used in data science. So we will be discussing about all those libraries, how they are used in the real world, what are the applications of those different libraries, when and where you would use these libraries. All those things we will be discussing in Python for data science. Let us go to deeper into what are the libraries which are used. First and foremost library is NumPy. NumPy, where we will be talking about how do we load data using NumPy, how do you compare your NumPy with traditional lists, what are the different data types, how do you perform indexing and slicing, how do you perform numerical operations, matrix related operations, some shape manipulations, how do you do statistical functions, resize, reshape, ravel, image processing using NumPy, and so on. So using NumPy, we will be performing all these operations, and then we will see like how we can perform these number-based operations using NumPy. The second one is Pandas. Pandas is also another important library. So Pandas, you could say like your basics of Pandas could be understood, loading data with Pandas. How do you do series-based operations? How do you do operations using data frames, selection and slicing of the data frames, descriptive statistics with Pandas? How do you do apply map iterations on Pandas using data frames and so on? How do you do working of your textual data? How do you do multi-indexing, group by, merging, joining? All these operations we will be using Pandas. Now Pandas, you can think like it is something like an Excel sheet. So you could do within Excel sheet, you could do a lot of operations. You could do selection, slicing, sub-selection, and all that stuff you could do using Pandas. In the similar lines, this is also the tool which is used for doing all those operations. Coming to data visualization, after doing Pandas, we will get into data visualization. There are two primary libraries for doing data visualization. First one is Matplotlib. Matplotlib is a library which is a basic library, but you could do a lot of plotting options with Matplotlib. We will understand about what is anatomy of Matplotlib figure, how do you do plotting of lines, and how do you change the colors, labels, add markers, histogram plots, scatter plot, size, color, and applying legend and skaters, displaying multiple colors using subplots. All those things you would understand using Matplotlib. Then you will understand about data visualizations using Seaborn. Now Seaborn is another visualization tool. What we'll do is we'll understand about how do you do plotting using Seaborn, what are Violin plots, box plots, cat plots, facet grids, swarm plots, pair plots, LM plots. Likewise, there are different types of plots using the library Seaborn. Now, Seaborn is much more richer than Matplotlib. When you want to create some kind of reports or dashboards or some kind of charts and so on, you will prefer using Seaborn because it is much more colorful. You could do a lot of colorful variety of plots are there. So for all those things, you will prefer using Seaborn. So visualizations, where do we use visualizations? Visualizations can be used both at the start of the data analysis and the end of the data analysis. Start of the data analysis, we need to understand what is our data, how is the data related, what are the different columns available, how are these columns linked together. So all these things we will be looking into the we will be so all those things we will be looking into, plotting all these things and perform different kinds of visualizations. Now these visualizations will help us understand the data well in advance. So before doing any analysis, we can identify which are the important columns, which are not important columns, how is the data segregated, and all that stuff. We will be looking into those concepts. But coming into the end of the analysis. So visualizations, we could do the end of the analysis. So in the end of the analysis, what we could do is, once we got the analysis, we can compare it. How is my accuracy? How well my model is performing? How far is it deviating from the actual results? So for all those things, sometimes my voice is not audible. Is it the case with everybody else? Is my voice audible? Okay. I think the voice is audible. Looks like there could be some internal issue with your system, maybe internet connection or whatever. So let me continue. If you still have that issue, you reconnect. Sometimes you can reconnect and it will solve the problem. Right. So the next one, what we are understanding is, once I perform this visualization, which can be done at the start of the analysis and at the end of the analysis. Start of the analysis will tell like what are my important features, how is my data related, is it too much convoluted? That means that one data point is overlapping on top of the other, or is it like having clear separations of margins? So we have clear separate areas of distinction. So how do we identify these analysis before getting into the modeling? uh, there you will use visualization, and after you create the results, once your model has provided some results, now we want to analyze how good my results are. So for analyzing all your results, for that also you will be using visualizations. So both at the start of the analysis and at the end of the analysis we'll use visualizations. After the visualizations, we will get into something called as exploratory data analysis. Exploratory data analysis is helping in identifying the patterns of the data, exploring your data set. As we said in the initial exploration, we need to find out how is my data represented, what are the important features, what are non-important features, so that I can remove those features. How do you perform some of the other operations? So all those things we could do using exploratory data analysis. So exploratory data analysis, we could do feature creation, evaluation of different kinds of measures. We could identify how to do data acquisition, data preparation, data cleaning, plotting of the variables, model planning and model building and so on. So inputting the data, reading the data to different text files, reading the data from the CSV and JSON, using some of the data preparation techniques or data pre-processing techniques like selection of the columns, removal of the columns, transforming, scaling, standardizing, normalizing, binarizing, one-hot encoding, imputing, train test splitting. So these are different types of functions are there which will operate on your data and do all these required operations. Sometimes you might have to remove some of the unwanted columns. Sometimes you might have some missing values, so you have to impute the missing values. Imputing means filling up the missing values. You have to fill up all the missing values, missing information. Then you might have to convert some of the categorical variables into numerical variables, do some standardization of your numerical variables. So all these different types of options are available, and this will be done in the exploratory data analysis. Within exploratory data analysis, we have something called as data pre-processing, and within that we will be doing all these operations. The primary purpose of that is to make sure the data is clean. So you remove the unwanted garbage, unwanted information can be removed, so that analysis can be straight to the point, rather than we including all the data and trying to beat around the bushes. We are trying to go straight to the point, and then we only identify the real important ones and then analyze the data and then get the results quickly. So garbage, if you are giving to the model, it will give garbage results. So we want to ensure that the data which is given to the model is clean, so you don't have all these problems. So once we complete the exploratory data analysis, we will get into something called as machine learning. So in this topic, this is like introduction to your machine learning. So by this time, we will be almost like completing almost a month worth of content. So doing all the basics of statistics and mathematics and Python and exploratory data analysis, we will almost be complete like a month or so. And after that, we will be understanding machine learning. Machine learning, we will be discussing about different types of models of machine learning. What is machine learning? What are the different applications? Classification and regression techniques. What is unsupervised machine learning, reinforcement learning, different advancements in machine learning, model representation, model evaluation, hyperparameter tuning of machine learning models, evaluating different machine learning models, estimating the prediction of the machine learning models and deployment strategies. All those things we will be discussing in the basics of machine learning. Here we will be understanding what are the different techniques which are used, what are the different approaches, all those things we will understand in this. But in the later sessions, we will go deeper. For example, supervised machine learning is a subset. Supervised machine learning classification is a subset of machine learning, which is primarily focusing about classification use cases. That means that we are trying to predict whether the output is belonging to one or the other class. So if at all I have a use case of a HR analytics use case where you get a bunch of data points, and then we have to analyze whether the person will leave the company or not. We're trying to identify the attrition problem. We're trying to see if the person is going to leave the company or not. That is how we could do it. Classification problems, you could take multiple examples: spam email or non-spam email, a person whether is having diabetes or not, yes or no. So diabetic, non-diabetic. So output will be in terms of classes, yes or no, true or false, A, B and C. Likewise, we will be detecting either binary classes or multi-classes, binary classification or multi-class classification. So we would be using a lot of algorithms here. So we have k nearest neighbors, decision trees, naive Bayes, stochastic gradient descent, support vector machine, random forest, gradient boosting machines, XGBoost, logistic regression. Likewise, we have a lot of these algorithms which will be used for finding the classification problems. We would also try about different methods. There are different methods like how do you combine different models, what is a bagging technique, what is a boosting technique, what is a voting classifier, how do you choose best method using all these operations, how do you do model tuning, train test splitting, k-fold cross validation, variance bias trade-off, what are the different norms, L1 and L2 norms, how do you perform overfitting, underfitting of the models, how do you perform hyperparameter tuning using grid search CV. All those things will be available in model tuning. Model tuning is nothing but you start with a model, it gives some results, then you try to change some of the hyperparameters, you tune the hyperparameters so that you get even better results. That is called as model tuning. Similarly, you could also identify different performance measures, mean absolute error, mean square error, root mean square error, and different things like accuracy, confusion metrics, precision and recall. Likewise, there are different types of things which are available, and all those things we will create as a different kinds of performance measures. So this is about supervised machine learning classification. After we complete that, we will get into supervised machine learning regression. Supervised machine learning regression is a quantity in which we are trying to predict regression values, which are continuous values. So what are the continuous values we are trying to predict? We are trying to predict a continuous kind of outcomes, which are so you have linear regression, variants of regression like lasso and ridge regression, multilinear regression, logistic regression, regression model improvement, polynomial regression, random forest regression, support vector regression. Likewise, we have different types of regression functions, and all those things could be used for finding different regression elements. Similarly, we can also find out performance measures like how do you calculate mean absolute error, mean square error, root mean square error. All those different performance measures which are used in regression quantities will be identified here. Once we complete both classification and regression use cases which fall under supervised machine learning, we will get into something called as unsupervised machine learning. Unsupervised machine learning is like a technique in which we do not have something to predict, but we are trying to identify patterns of the data, and then we are kind of creating some groups or segments or clusters, right? So we don't have a specific outcome. We are not predicting some X or Y or Z. We don't have an outcome, but we are trying to create some of the meaningful groups by finding similar patterns, and based on the similar patterns, we can do the grouping. So clustering, you have k-means clustering, you have hierarchical clustering, DB scan, and so on. Association rule mining, we have association rule mining based techniques, market basket analysis, a priori algorithm, dimensionality reduction, principal component analysis. Likewise, we have different types of techniques which are used for finding these associations of your data. You have different clustering techniques and association techniques. Clustering means k-means, hierarchical, and DB scan. In association, we have different associations like market basket analysis, dimensionality reduction, and so on. Once we are done with it, we'll get into something called as natural language processing. Natural language processing is where we are dealing with the natural language text. So different essential components are there, different natural language components are there. So we are doing text analytics, stemming and lemmatization, stop word removal, parts of speech tagging, name entity recognition, bigrams, n-grams, collocations. How do you perform term document metrics? How do you perform count factorizer, term frequency and term frequency and TF-IDF, which is term frequency, inverse document frequency. So likewise, we have different techniques in which we can convert textual data into numbers. Okay, machine learning models primarily work on numbers. So for giving the numbers to the model, we have to convert all the texts into corresponding numbers. So imagine you have a bunch of Amazon comments, and the comments you have to convert into the number form. You could perform either a count vectorizer or a TF-IDF vectorizer, which can convert all these words into corresponding numbers. But even that, we have to see like how do you perform some of the basic other operations how do you remove unwanted words from your text. There is something like stop word removal. There is something like techniques like stemming and lemmatization. There is tokenization. So likewise, there are different techniques in which we remove the unwanted words so that we only have the words which are very important, and then we can take those comments and convert into numbers and then feed them to the corresponding machine learning models. For doing all those things, we would need to learn about different natural language techniques, and this topic would cover all those areas. So once we have completed with all those things, we will get into a little advanced analytical techniques. We will see some examples of time series analysis, ARIMA models, content-based recommender systems, collaborative-based filtering, and so on. So likewise, we have different kinds of models which will be used related to the time series forecasting or recommender systems. Those will be covered in the little advanced analytical techniques. Once we are done with it, we can discuss about something called as reinforcement learning. Reinforcement learning is a technique in which we have different components of reinforcement learning. We have basic components of reinforcement, action and reward based techniques, penalty based mechanisms, feedback loops, and how do you use deep learning, especially deep Q learning for doing the reinforcement. Once we complete all these topics of machine learning, we will get into the artificial intelligence and neural networks. Those are the newer areas in which we are using neural networks for determining the outcomes of your models. They are typically called as deep learning models. Deep learning models. So we will understand, firstly, we will understand what is artificial neural networks, what are the neural networks and their terminologies, how do you do non-linearity problem identification, what is a perceptron learning, what is a feed-forward network, what is a backpropagation, how do you perform gradient, what are the different mathematical techniques which are used for doing artificial neural networks, like partial derivatives, linear algebra, eigenvectors, projections, vector quantizations, all those things. We will see like how do you perform all those operations. Those are the things we will discuss. Similarly, we can do an overview of the tools. For example, overview of the neural networks, TensorFlow and Keras, like that, and different models like deep learning. We will see like how deep learning can be applied. How do you use tools like TensorFlow and Keras? How do you identify accuracy using hidden Markov models? Using deep learning for doing image-based predictions, sales prediction, image similarity comparisons, and so on. We can also understand something like convolutional neural networks. Convolutional neural networks are the techniques which are used for identifying image-based comparisons. For example, I show some photographs and it has to identify what is in the photographs. So image analysis can be done using CNNs, which are called as convolutional neural networks. So we'll understand what is the architecture of CNN, what are the different layers which are available in CNN, different filters which are available, how to build an image classifier with and without CNN. So likewise, we have different techniques which could be used for determining these. The next ones we can follow is the recurrent neural networks. In the recurrent neural networks, we will understand how to perform recurrent actions. So fundamental recurrent neural networks, how do you handle different sequence length RNNs, how to perform a sequence classifier by training and predicting the time series of that. So all those things can be used in RNNs. Next one is next important topic is cloud computing for data science. So once we complete all these basic topics, we then need to know like how to deploy these models. So you create a specific algorithm, random forest or support vector machine. and then you get an output accuracy, you got some result, you created a outcome as a model. Everything is good, but how do we deploy these models? Where do we deploy these models? What are the different areas which are necessary? That we will be covering in cloud computing for data science and DevOps for data science. So these are the two topics which are very important. First one is cloud computing for data science, where I will be primarily talking about AWS cloud, but we will also discuss about Microsoft Azure. These are the two clouds which we'll be talking. I have a good expertise in AWS, so I will be primarily talking on AWS, but we will be also talking about Microsoft Azure. So within this cloud computing, we'll understand what is the basics of cloud computing, what are the different services which are used in AWS cloud, for example, S3, EC2, RDS, what is a elastic MapReduce, how do you perform machine learning using Amazon SageMaker, how do you use deep learning based techniques, natural language using AWS, and different analytical techniques, data warehousing techniques, and how do you create the end-to-end pipelines for deployment of the models. All those things we will be covering in the course. So this course covers the AWS. So it does not cover the cost to spin the EC2 machine. So if you have a free AWS tier, what we call as a free tier, if you create a new account, for the first 12 months, you can use some of the basic versions which you can run for free. So we will recommend to create the free version so that you can take the advantage of all the free services. So cost of spinning up a EC2 machine, that will be covered in that. All right. But there are some services, for example, you go for elastic MapReduce or some of the specific versions of the machines. So you go for a higher end machines like M5X large or 2X large, or some kind of machines which are like higher configurations. Then you have to pay from your credit card, right? It will take a credit or a debit card. You have to pay for that. But most of the services are free for the first 12 months. There are some conditions for that, like the hours of usage should not be greater than 750 hours or whatever. So there are some limitations, but those limitations are also very minimal. If you are just learning these topics, then those things should not be a problem. You will get free versions for trying out all these things. Understood? Once you complete the cloud computing concepts, you will get into DevOps for data science. Now, DevOps for data science is also very, very important. Now, a data scientist nowadays, he is not just only building models or doing statistical analysis. He or she will be responsible for pushing the models into production, making them productionized, monitoring those models, ensuring uh, the quality of the models, and how do you identify what is going wrong with the models and how do you correct them in the due course of the time. All those things will be done by the DevOps person. A data scientist could have a depth in data science but should have breadth in cloud computing and DevOps. So here we will talk about different introduction to DevOps topics, different tasks in data science development, deployment of these models in production, deployment of machine learning models using containers, Dockers, and so on. How do you scale these machine learning models using Kubernetes? See, all these different things we will be learning in this area. All right. So total of 16 modules are there. If you are talking from right from the start till the end, what we discussed is starting from mathematics for data science, statistics for data science, Python for data science, then getting into machine learning, supervised, unsupervised machine learning, reinforcement learning, natural language processing, advanced analytics, then cloud computing for data science, and DevOps for data science. These are all different areas which are going to cover in the coming few months. I would also quickly talk about different projects we are going to talk. So we'll start with some of the basic projects, like how do you do XML to CSV converter using Python? How do you do a photo editor using NumPy and Flask? Exploratory data analysis on retail shop sale data. Different industries are there, different tools will be used. Fruit prediction using KNN algorithm. So these are some of the starting toy projects which will help us to understand all the nuts and bolts of creating algorithms. Once we are comfortable, then we'll go into healthcare, predict malignancy in mammogramic masses using decision tree classifiers, predict whether a candidate will be shortlisted in H-1B visa processing using random forest algorithm, predict breast cancer using support vector machine, HR analytics attrition prediction using logistic regression, churn analytics in telecommunications, predicting housing prices using regression, social media network ad prediction, retail customer segmentation based on their spending patterns, market basket analysis using a priori algorithm, spam detection and natural language processing, SMS spam detection, and sentiment analysis on restaurant reviews and natural language processing and supervised machine learning, image classification using deep learning, content-based recommender systems and deep learning, chatbots using recurrent neural networks and deep learning, stock market prediction, and exploratory data analysis of crime records in Boston. So all these, what we are saying, we are having close to 20 mini projects. Apart from this, we will be doing two major projects, which will be like end-to-end representation. Of course, these mini projects are also end-to-end representation, but they will be talking on one specific algorithm. While we are learning the algorithm, we will be doing practical projects so that we will understand like how we do all these coding in the real world. What are the practices which are used for analyzing these data sets in the real world, for implementing models in the real world. All those things we will be discussing during these project discussions. Understood? So these are few projects, but we will be doing much more than this. See, what I would recommend is I want you guys to identify your, maybe in your industry areas or whatever, try to identify what are the different applications which are used in your industries. Maybe you are serving for a healthcare industry, or maybe for manufacturing, or retail or banking, insurance. It doesn't matter. So we try to identify some real world use cases. Most of the things we will do it. But if you have any of the use cases within your company and you want to build your portfolio or your resume or something like that, we could try those concepts. We would encourage people to come forward with their own application areas, their own use cases, so that we will analyze that. So such kind of things, what we have done in the past, that people have come up with their own specific use cases, we have solved them, and they could use that in their resumes and then project it as their projects, so that they will get better opportunities. So we encourage people to do such kind of inclusive learning. So when we come up with our own topics, we come up with our own examples, application areas or use cases. So we could analyze that and then we will get outcomes. Got it? Any questions on what we discussed so far? Understood, right? You understood you should get a basic picture about what we are going to cover in the course, right? If you have any questions, please put that in the chat window. I will be happy to answer any of the questions you might have. So regarding the certifications, do we get any help? Yeah, once we complete this course, right, we will be good enough to crack the certifications. There are specific certifications from Azure and AWS and all. So I am an Azure certified data scientist, Microsoft Azure certified data scientist. So if you are interested in doing those certifications, I will be able to help you. Like what type of questions would come, how do you tackle tackle those questions and all, I'll be able to help it. But these certifications will be little product specific. If you're taking Microsoft Azure certification, they will be little biased towards their products, like how do they use Azure's specific machine learning products, or what are the settings which are used in Azure machine learning. So you need to have a little more understanding on those topics, but they are doable, right? I'll be able to help you in cracking those certifications. You could just say Microsoft Azure certification. It will be DP 100 or something like that. So that will say Microsoft certified Azure data scientist. Got it? Any other questions? All right. So we'll come. So So there is a question that for somebody like a fresher, can the person directly join, or can they do Python and come back? That is purely based on your understanding and all. I would not suggest something, do that first and then come here. There are people who wait, who first to do Python programming and then come to data science, and then there are people who are parallelly doing that also. So Python will take, as we saw, the first 1 month we will be covering mathematics for data science, statistics for data science, Python for data science. So in 1 month you will be able to learn Python from basics. So you will be able to do it. That is a good enough time. So parallelly, they will be learning this theoretical based knowledge only from our topics. So we will be learning about how to use mathematics, statistics, and other things. So they will be comfortable. So if people can do it, they could do it. But it is case on case basis. So it depends upon your understanding. So you could take the decision. I might not be able to give you an answer to that. So question is, when we need to come up with your own real-time scenario. So you could start thinking from right away, start from uh, in the first month itself, that what are the different applications which our company is handling. What could be the possible areas where I could collect data and do some analysis? What are the areas where I could apply some model and I can do some future predictions? So you could ask these questions in your business itself. Business means, I am not saying that you ask your business stakeholders or whatever. I'm trying to say is identify answers for these questions. Then you will know like what are the applications. Once we know the applications, then you could use that for your practice. Got it? Yeah. Any other questions? So what we'll do is generally we'll have 45 minutes to 50 minutes of our session, and in the end, say like 5 to 10 minutes, we will give for questions. So if you have any questions, you could post either in the chat window, or we can stay to the end and then we can ask the questions, so that it will not hamper the flow of the session. Sometimes what happens, people interrupt between the session and then hamper the flow. Then there are a lot of these complaints saying that, sir, can we keep the sessions in the end and like that. So as a best practice, what we will do is we'll keep like 5 to 10 minutes in the end, so that any doubts are there, any questions are there. So when we go deeper, right, when we go into technical topics, you might get some doubts. So we could ask, either you could put in the chat window, I'll see the chat and then I'll answer them as and when possible, or we could keep it in there so that it is not cutting the session or hampering the session in any way. Understood? So that's how we will take it. We'll come back tomorrow at the same time and we'll discuss about what are the applications of data science. What are the different applications of data science? What are the different concepts which are used in the data science? So we'll talk about those things in the coming few sessions. But till then, take care and have a nice day. I'll meet you tomorrow. Bye bye.